This example is very similar to some of your homework problems. You're given a set A here, the set containing the numbers 1, 2, 3, 4, and 5, and a relation has been defined by this adjacency matrix. And what you're supposed to do is select which of these properties the relation, we'll call it R, satisfies. All right, now the way that I personally would go about this problem is that I would first graph the relation, draw the graph of the relation, and then use the information that I gave in the previous videos to help me determine which of these properties, if any, that the relation satisfies. So that's what I'm going to do here. First, what I'm going to do is I'm going to turn this adjacency matrix into what I've called a adjacency table. And adjacency table isn't really an official term, that's just my term. But I think it makes sense. So 1, make that a little better there. 2, 3, 4, 5. 1, 2, 3, 4, 5. And remember, like I did in previous videos, this is where we start. This is where the edges start, and this is where they end. All right, so there's 5 vertices labeled 1, 2, 3, 4, and 5. So let's just start by writing out some vertices. Let's see. 1, 2, 3, 4, 5. Okay, now this first row tells us that starting at 1, there's an arrow or an edge from 1 to 3 and 1 to 4. Okay, so let's draw that in. Like so. Okay, second row there tells us there's an edge from 2 to 5. Okay, third row tells us there's an edge from 3 to 2. Next row tells us there's an edge from 4 to 1. Okay, I'll draw that in. Let's see. 4 to 1, 4 to 3, and 4 to 4. So a self loop. And this last row says there's an edge that starts at 5 and ends at 3. Okay, 5 to 3. All right, so there's our graph of the relation. Now using the information that I gave in the previous videos, you could just look at this graph and tell whether it's reflexive, antireflexive, symmetric, antisymmetric, and or transitive, or none of the above. And that's a perfectly fine approach to this problem. But what I personally would do, because I like visual things, I like doing drawings, I would redraw this thing. Just make it look a little nicer. All right, so your first drawing, like I gave here, it's hard to tell how things are going to look, so you just draw the vertices in kind of a circle, circular pattern or what have you, and then go ahead and draw arrows between them like I just did. Then you might notice that, oh, you know, if I move some of these things around, it might be a little more clear. And so what I'm seeing here, and I'll draw this in red, is that notice that if I took this vertex labeled 5 and I moved it over here, then things would be a little less jumbled. All right, so I'm going to do that now. So I'm going to have 1 here, 4 here, 2 there, 3 there, and now 5 I'm going to move over here. And now I'm just going to use the adjacency table again. You could just tell where the arrows go from looking at the previous graph if you wanted to, but I'm just going to use the adjacency table. Okay, 1 goes to 3 and 4. All right, so 1 goes to 3 and 4. 2 goes to 5. 3 goes to 2. 3 goes to 2. 4 goes to 1. 4 goes to 3. And 4 goes to itself. Okay, and lastly, 5 goes to 3. Okay, so there's a little more clearer version of the graph of the relation. Notice that these two graphs contain the exact same information. So it doesn't matter how you draw them. The length of the edges doesn't matter. The position of the vertices doesn't matter. They both contain the same information. And so now looking at this last graph, I'll just, I can tell right away from my video that I have on graphing reflexive relations that this is not reflexive. All right, so that's out. I can also tell that it's not anti-reflexive. Let's see, it's not symmetric. Why is that? Let's see, well, there's this arrow here, but there's no arrow going back. Okay, so that's out. I can tell that it's not anti-symmetric. I can see that right in here. Okay, so that's out. And I can also tell that it's not transitive. Why is that? Let's see. Here would require that. We don't have that. So it's not transitive. Oops. Erase that instead of crossing it out. Anyway, cross it out. So therefore, it's got to be none of the above. And that's it.